Okay, so we're going to work on our review sheet for right now, for today. We have a big test tomorrow, and it's on solving trigonometric equations and graphs. Take a look at question number one. 2 sine theta plus rad 3 equals 0. So how do you solve something like this? Well, what I would do is I would simply take some of these degree amounts and plug them in for theta and find which one of them works. So let's take a look at this particular option. Right? What do I mean? I mean, make sure your calculator is in degree mode. Okay, so make sure your calculator is in degree mode. Do that by hitting the mode button, making sure it's switched on over here. Then we're going to enter some choices like, let's try out choice number one, 60 degrees. 2 sine 60 plus the square root of 3. Does that equal 0? No, it doesn't. So that means that you can automatically cross off this one and cross off this one because they have 60 in it. Now we're going to try the remaining two. So let's check it out. 2 sine 150 plus the square root of 3. This one doesn't work also either, so it must be choice C. Now I'm going to show you how to do this longhand also as well, but that was an easy way to do it in the calculator. If you wanted to try and do it out longhand, here's what you would do. So you would subtract rad 3 from both sides and get 2 sine theta equal to, sorry about that, equal to the negative square root of 3. Right? Divide both sides by 2. You get that the sine of theta equals negative square root 3 over 2. And then you would inverse sine it, right? What's the inverse sine of negative square root of 3 over 2? Well, let's see. Let's use our calculator. We're going to inverse sine this. Inverse sine of negative square root 3 divided by 2, and that's negative 60. Now normally that would be okay. The problem is that you have this restriction right here, and that theta's got to be between 0 and 360, and negative 60 isn't in that range. So here's what you do. You say to yourself, well, what do I have? I see that the sine of theta is a negative number. Where is sine negative? Well, sine stands for the y coordinates. Sine is negative in the third and fourth quadrants. So I'm going to draw in a right triangle right here, according to the bow tie that we learned before. Negative 60, well, this helps me find the reference angle. It means that angle right there must be 60 degrees. And so from here, here's what you do. You say to yourself, well, what angle measurement do I need to go all the way around like that? Sorry about that. And 300. 300 gets me there. And 300, as you can see, is one of the choices. Now, how did I get that other 240? Well, here's how. You get 240 by drawing the other reference angle, drawing the other triangle into the other quadrant where sine is negative, and that's the third quadrant. Just same triangle, 60 degrees over here. And then you want to find what angle measurement gets me from here all the way down to this side over here. And that's going to be 180 degrees plus the 60 more that you have to go this way. And 180 plus 60 is 240. 240 and 300. And that's the long way of doing this problem. All right, problem number two. Problem number two. Well, we can use the same kind of process that we did before. Let's do it shorthand. Let's do it shorthand. Shorthand by meaning I'm going to take a cheap shortcut. Here's what I'm going to do. 2 cos squared theta minus cos theta equals 0. I'm just going to try plugging some of these in, see if they work. How do you plug in this squared business when it's next to the cosine? Well, here's what you do. You do 2 cosine. Let's try 90 degrees. Let's see if it works. 90 degrees, and then you put the squared outside over here. Minus the cosine of 90 degrees, and that equals 0. So 90 is one of our options, which means that it can't be D. So 90 works. Let's see what else. Maybe does 30 work? I'm going to cut and paste my answer. And I'm going to try 30. Nope, 30 doesn't work. So that means this one's out. Now let's try and see if 60 works. Otherwise, it's got to be choice A. And that one's 0, and so 60 does work. And so it must be choice A because it has a more complete answer set than, it must be choice B because it's got a more complete set of answers than choice A. Problem number 3, the graph in the accompanying diagram is a reflection in the x-axis of which of the following equations? Well, look, it's a cosine, it's a sine graph. So obviously it's not u and it's not u. Now it's a question of whether it's a sine 2x or it's y equals sine x. How much of the sine curve do you see between 0 and pi? You only see half of it. I'm sorry, you actually see half of the sine curve between 0 and pi, which means you'd see the whole sine curve between 0 and 2 pi, which means it can't be this one because the frequency, this number right here means that you should have seen 2 of them. So it has to be choice D. But don't really worry about this problem too much. You're not going to see it tomorrow. It was a tricky one. Here's something that you will see tomorrow. Okay. Let's take a look. Whoops. Sine 3x plus 3. What's the phase shift? Well, let me show you how to solve that. You're going to have to factor out that 3, put it in its expanded form. Right? There's a 1 over here. That's the amplitude. This is the frequency. Right over here is the phase shift. And there's nothing on at the end. That would have been movement up and down. So let's take a look. The phase shift. Well, plus inside of the parentheses, phase shifts, moves the graph in the opposite direction and you would think it would. It's not moving it to the right. Plus 1 means it's actually going 1 unit to the left. Now, which set of values represent the amplitude, period, vertical shift, positive and negative, and phase displacement? Let's use a tactic on this problem of just eliminating choices as we go through it that don't make any sense for the problem. Like, for example, the amplitude. Well, what is the amplitude? Amplitude is just the absolute value of this first number right here. So what is the absolute value of 23? The absolute value of 23 is just 23. So that means you, my friend, are out. Can't be you. Let's find the period. Okay, the formula for period is 2 pi over b. What is b? B in this particular case is 3/4. That's its location. So that's going to be 2 pi divided by 3/4. 2 pi divided by 3/4. Well, just simplify this aspect of the fraction. It's going to be 8 pi over 3. So you're out, and the answer must be choice B. What's the range of this function? Well, range is movement up and down. Let me show you what the graph looks like by plotting it in my calculator. I'm going to go into my window. I'm going to adjust my window. Let me show you from, I'm going to see a normal looking picture that's from 0 to 360. Whoops. 0. This is going to be 360. We're going to scale it by 90. Our y min, let's not make it too big. Let's make it like -3 to 3. I arbitrarily chose that, and I would fix it if it didn't work. And now let's enter our graph. 2 sine 3x. Take a look. So here's what the graph looks like, right? The 3 means that you should actually see 3 of them. The 2 in front means it's the amplitude. So take a look. The amplitude, how high or low it goes. It goes down to -2, goes up to 2, and the range is the movement up and down, right? It's the possible y values where this thing exists. And so the answer is just A. Which graph is represented below? Well, let's use our calculator, right? Um, my window's already set to 0 to 360. That's 0 to 2 pi. I just don't feel like making my calculator in radians. And it's going from -3 to 3. So now I'm just going to plug in choices. Well, 2 sine 3x, take a look at it. It's definitely not this one. You're out. Let's see, 3 sine 2x, 3. Oh boy, not you either. A half, I can eliminate this one because that half in the front means it would only have an amplitude of a half. And this one's got an amplitude of 3. Nope, you're out. Let's try it and check out choice D. 3 sine 0.5x. Ah, perfect. We can already see it's taking good shape. It's choice D. A certain radial wave travels the path represented by this equation. What's the period? Well, period is represented by this formula, 2 pi over b. That's the formula for period. B is this number right here. So it's going to be 2 pi over 5. I'm sorry. My mistake. No, I'm so dumb. It's not 2 pi over 5. Silly person. It is 2 pi over 2. These cancel away. I'm just left with pi. And so there you go. It's choice C. What's the period of this function? Well, I really need to know what b is. So here's what we got. We're going to need to put this in expanded form. 1/2 sine 1/3 x minus pi. Just rewrote this portion of it. Now, let's expand it out a little bit. I'm not changing it. I'm just rewriting it in a little bit of a different way. So that's going to be 1/3. I'm going to factor 1/3 out of each one of these. That'll leave me with x. And 1/3 factored out of this will actually produce 3 pi. It's not really going to be very important, but I just feel like you should see it. Now, what's the period? Well, this number right here is b, and so I'm going to do 2 pi divided by 1/3. 2 pi divided by 1/3, you know what that is? 6 pi. What number is not in the range of this? Well, the range of sine x goes from -1 to 1, and so 2 is not in the range. Determine the amplitude. The amplitude is just the absolute value of this number. The absolute value of -4 is 4. The path traveled by a roller coaster is modeled by this equation. What's the maximum altitude? Well, if it were centered at the origin, it would go up to 27, but it's been shifted up by 30 units. So 30 and 27 is 57. What's the period of this graph? Well, this is just a formula that you need to know. Period is 2 pi over b. Which graph represents a sound wave that follows the curve whose period is pi and that's in the form of a sine bx? This graph over here is cosine curve. Just cross it off. A period of pi, that means you'd see one full sine curve over the course of pi, like pi distance. And so over the course of 2 pi, you should see two sine curves. This one has 3 of them. This one only has 1 of them. So it's got to be this one. Which graph has an amplitude of 2 and a period of pi? Well, you're out because you have an amplitude of a half. Period of pi, we're looking for the one for which 2 pi divided by b has to equal pi. So what does b have to be for these two equations to be equal to each other? B's got to be 2. You're out. You're out. Which of the following best represents the graph of a secant of x? Let me show you how to do this in your calculator. Secant of x, just so you know, is 1 over the cosine of x. And so we're going to use our calculators to graph that out. Here we go. Turn our calculators on. We're going to go from 0. Whoa. Okay, let's try and see 1. Whoa there. 1 divided by the cosine of x. Graph it up. Boom. 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 That's you right here, buddy. Cosecant of x. I remember which ones go with which by saying no two cos go together. Like cosine goes with secant. Cosecant goes with sine. And so now I'm just going to try and plug that into my calculator. Try and graph it up. 1 divided by the sine of x. And I think it most resembles this one over here. Cotangent of x. Well, you know, the cotan of x is the same thing as saying 1 divided by the tan of x. Okay. So, now let's take a look. Let's check out our calculator. So that's going to be 1 divided by the tan of x. And let's see what we got. Well, I can tell you one thing. It's not A. It's not B. It could be a close call between C and D. No, it's D. Short answer type questions. Now I'm going to take my time on these because you're going to have to show out all of your work. All right, 2 tan x plus 2 equals 0. Let's see. So 2 tan x plus 2 equals 0. Subtract 2 from both sides. So you get that 2 tan x equals negative 2. Divide by 2 each side. Tan x equals negative 1. Now, how do we find x in this case? You're going to have to inverse the tan. Tan inverse of negative 1, I'm inversing this negative 1, equals, let's see. Okay, negative 45. Now, that's a completely appropriate answer normally, except that it tells you that x has to be between 0 and 360. So here's what you say to yourself. Okay, so tan of x equals negative 1, and this kind of tells me the degree amount. Let's try and graph it up, use our unit circle, figure out the quadrants. So where is tan negative? Well, tangent is negative in the second quadrant. Okay? Tan is negative in the second quadrant, and tan is also negative in the fourth quadrant. That's what this is telling you right here. That 1 degree amount is negative 45, which puts me over there. Now, how could I swing around this circle and get negative 45? Well, the degree amount needed to get to this location is the following. In order to get to here, it has to be 315 degrees. And watch, check this out. The tangent of 315 degrees is negative 1. There, perfect, good to go. All right, whoops, sorry about that. Now, what about the other one? What about the other one? Two triangles, right? This one was 45. I'm telling you that this triangle over here, man, will also produce a negative tangent, a negative amount for tangent. But what's the degree amount needed to get to this location? Well, how much is it to get to right over here? That's actually 135 degrees. Now let me show you something. Plug that into your calculator. The tangent of 135 is negative 1. And so that's the other amount. So let me give you your final answer in the end. And put it in red. Let's see. X equals 315 degrees. Or X can be 135 degrees. Okay, problem number 20. This one's going to take a while. First thing that we're going to do is we're going to make the problem easier to solve by using variables instead of sine x's. I'm going to say that x equals the sine of x. All I'm making is a substitution to make the problem look easier. So then the problem becomes, whoops, sorry about that. Then the problem becomes the following. It's going to be 2x squared, right, because x now stands for sine x, minus x equals 0. And so we're going to factor out an x. We're going to get 2x minus 1 equals 0. Oops, oops. Right? Set it equal, so x equals 0. 2x minus 1 equals 0. 2x, I'm going to add 1 to both sides. 2x equals 1. X equals 1 half. All right. Now I'm going to sub back in. So, sine of x equals 0. And sine of x is going to be equal to 1 half. Now we're going to have to find these two locations. Let me deal with this one first. This sine x equals 0. I'm going to deal with it over here if you don't mind. Let me deal with it in red. Where does the sine equal 0? Remember that sine stands for the y coordinates when you're dealing with the unit circle. So where are the y values 0? Well, there's 0 right here, and there's 0 right here. And this is going to be 0 degrees, and this is going to be 180 degrees. Also, if you memorize that table from a while back, that'll also tell you where to go looking for it. If you don't believe me, check this out. Sine of 0, 0, sine of 180 is 0. Yeah, we're good to go. Okay, so now we got to do this one. I'm going to do that in a bit of a different color. Where is the sine equal to a half? Well, there's two separate scenarios for this one. Okay, first of all, sine is equaling a positive number. So one of the triangles that will get you a half for sine lies in the first quadrant. And maybe our calculator will help us find the reference angle. So we are going to inverse sine of a half and see if we can't figure out what this reference angle over here is going to be. Inverse sine of a half is 30 degrees. So 30 degrees goes right over here. 30 degrees is one of the possible answers. Where's another possible answer? Where else is sine positive? Sine is also positive in the second quadrant. The reference angle over here is 30 degrees, but how much is it to get to this spot? 150. So, what are the possible answers for this problem? Well, possible answers are the fact that x can equal 0. That was one answer. 180. That was another answer. 30 degrees. That's another good one. Whoops. Give them all little degree symbols. And finally, 150. Okay, finally, last one. 2 cos x. I'm gonna subtract 3 from both sides equals negative radical 3. I'm going to divide by 2. So cos x equals negative rad 3 over 2. Okay, and I'm going to inverse it. Cos inverse of negative rad 3 over 2. How much is that? That's going to tell us what x is. Is 150. Okay. Whoa there. That's all right. So what does that tell us? Well, cosine ended up being a negative amount, and there's two possible locations for that. Okay, cosine is negative in the second quadrant and in the third quadrant. When we punched it into our calculator said that, you know what, 150 degrees gets me one possible value, but that also leaves me a reference angle of 30 degrees in this triangle. So using this triangle and flipping it into the other quadrant where cosine is negative, right here. What's the other angle? Well, let's see. The other angle is 180 plus 30 to 10. And so our final answer is that x is going to be equal to 150 degrees and 210 degrees. That's it.